Hello, thank you for watching. My name is Professor Void. If you like what you saw here, make sure to subscribe, leave a comment, hit that bell. All right? Hit it. Hit the fucking bell. This looks cool as fuck. Y'all ready to get a butt full of knowledge? Sometimes I catch myself. All right, let's. I gotta calm it down with the funk here. I get too into it. All right, that shit was called Woodworking. That's what that title was.
Human brain is the most powerful supercomputer in the world.
All right, let's see this electrical headquarters of yours in operation.
It helps us navigate our environment by carrying out about 1,000 trillion logical operations per second.
And one of those logical operations was us having a couple drinks together. That's what I'm saying.
It's compact, uses less power than a light bulb, and has potentially endless storage.
The human brain is really one of the most complex systems that we can imagine.
You gotta warn me. You gotta warn me. When we're gonna throw in a German accent and we're talking about experiments and brain shit, you just gotta warn me, all right? Just, whoo, damn, that came out of nowhere and got me worried.
We have a fundamental lack in our understanding of the way the components in the brain interact. But it is this very interaction that generates cognition and consciousness.
All these mind-boggling...
You see, right there, babe, right there, that is where, like, the alcohol came through and told me to be horny. It's my brain, babe.
Intricacies have driven our fascination with the brain, and for centuries we've been trying to map and understand it. And most recently,
that is in our head. Like, that's fucking wild. That keeps baffling me. Like, that's in our head. This bussy. That's like right in your noggin, dog. Look at that slit. It's all bumpy as fuck, too.
Recently replicated.
The brain is certainly a computer that has been evolving for nearly 4 billion years. And the more we learn about the brain, the more we're able to incorporate the smart ways that it does computation into our artificial devices.
Scientists are beginning to agree that to realize our technological dreams, we need to build computers that work like our brains. One day, these computers could in turn help us unlock more secrets of cognition.
Yeah, they can teach you not to be a fucking horny asshole, John. I'm telling you, babe. What do you want me to do? I'm only human, babe. Understanding's the brain.
The brain is packed with neuron cells that constantly communicate with each other through electrical pulses known as spikes. Each neuron releases molecules that act as messengers and control if the electrical pulse is passed along the chain. This relay race is happening simultaneously throughout billions of neurons. Much like the zeros and...
Oh, see? Right there. That's where the horniness came through. That's what happened. It was like, ba-bow, babe. That's what happens when I see you. That's what happens when I see you, babe. All right, I love you. That's what you make my brain do that. Yeah. Tell him, Doc. Like, so this is when you were... So this is when you threw the piece of paper across the room and it landed in the trash bin, like, perfectly. That's the activity in your brain. Oh. I mean, let's be honest, it was kind of cool, though, right? Indeed, les deux, sir. Yes. Is what the kids would say, Pog.
Ones of the computer world, this is the basic language of the brain. But understanding all of this isn't enough. we've still only scratched the surface when it comes to figuring out how the brain works.
The more I'm working on the brain, the more I understand how complex it is, how difficult it is. Many relatively easy cognitive functions cannot really be understood at the level of cells.
You see here, this here is a good brain. Yes, this is a well preserved. This is a well preserved human brain. What the fuck am I trying to? So, Wiener Schnitzel, yes. This is a good brain. Good brain, good healthy brain.
The human brain is one of the
The human brain is so delectable. Yes, I'm not alien. I am just German scientist. Yes.
the biggest secrets and mysteries that we have, despite many years of intensive work.
This is my work. Yes, after I eat brain, I went through trippy visuals, and I painted this with my body. Yes.
Katrin Amunds is at the helm of the Human Brain Project, a 10-year-long attempt at studying the brain. With researchers collaborating across 100 universities, the project is expected to cost around €1 billion.
Professor Amunds and her team are working on one part of it, a 3D digital brain atlas. They're creating 3 different high-resolution maps. One of neurons, one of their connections, which uses different colours to indicate the orientation of neurons' branches, and one...
What the hell's going on here? You mean to tell me? You mean to tell me, goddammit? What the hell's this? You telling me there's gay in my brain? The hell's going on here? Huh? Nah. That should be just red, white, and blue there, partner. You gonna tell me that I got the gay in my brain? Hell no. The hell this German scientist want to tell me that's what they want to put in your brain? That's COVID-19.
Which uses different colours to indicate the orientation of neurons' branches, and one map of the receptors for the messenger molecules.
When we think about an atlas of the world, we can map all the different countries. But then we can also see there are maps illustrating the level above the sea or the temperature. And it's a little bit like what we have in the human brain. There are different aspects. We want to understand where the cells are located. We want to understand where certain areas are located, how they are connected, what is their molecular profile, what is their gene expression that is important for function. So there is not one single aspect that can explain everything in the human brain. So that means we need different types of maps that reflect different aspects of brain organization.
You need a fucking, you need one of them NVIDIAs there, Bobo. Yeah, you need one of them NVIDIA 390s. That'll run up your graphic there processors. Okay, there's a bunch of animators. Don't worry, Unreal 5 just got thrown in there. You'll be real good. We shut up. Just upload Unreal 5. Yeah, then throw about 390s on there. We'll get your human brain right up and going. A whole fucking simulation there. Yeah, treat you real good.
To create the maps, the team is scanning slices of post-mortem brains.
We get brains from body donors and process them, embed them in paraffin, and then cut them into 20 micrometer thick sections. 20 micrometers, this is approximately like thickness of one hair, so this is very thin. One brain has approximately 7,000 sections. These sections can then be analyzed under the microscope, and we can then reconstruct the areas in 3D.
Much like a fingerprint, every brain is unique. So to account for these differences, the team scanned 10 brains for each of their maps.
This generates petabytes of data that's analysed with the help of AI and used to run brain simulations on supercomputers. But even the supercomputers struggle. So to further our understanding of the brain, we need better machines.
Yeah, look at that. Yeah, no. This is just this is just a COD server room. Yeah, this is where they go to play LAN parties and stuff like that to fucking download their 500 megabit fucking game.
We cannot make our chips much faster without them melting, unless we design completely new architectures. We cannot make our components much smaller because then we reach component sizes where quantum effects take over.
You could say that we need some more power, yes. If we had something like the Americans would use, then we would bring in some power. And we'll be able to remake your tiny brain. Oh. And then we could figure out how the American would work. But the closest we ever got to was a monkey. That is the power of German engineering.
So the computation becomes too imprecise to be practical. We need to find better solutions in order to increase our computational power.
Helsingborg University.
Mihai Petrovic, like many other scientists in the field, thinks that modeling computer hardware on our brains is the way to go. It will not only increase the speed and efficiency of future machines, but also help build better AI.
Woo!
There are certainly things that computers do much better.
That's what I tell you there. Them damn Germans, they're gonna build. They're gonna build the Terminator. Well, it's gonna be the Germinator. That's what it's gonna be. They're gonna call it that. Or the Americanator. It's gonna, or the Baconator. Oh, damn. Oh, God. I can really go for a Baconator right now. Yeah.
Better than brains, such as adding or multiplying big numbers, because this is what they were designed for.
Intricate problems in mathematics are accurately solved in a minute fraction of the time required for human calculation.
There is no evolutionary pressure for us to be able to multiply big numbers. Otherwise, certainly our brains would be able to do it. However, there is a strong evolutionary pressure to recognize your surroundings, to be able to build an internal model of your surroundings. When you hear a noise in the bushes, to be able to imagine that maybe there's a predator there. To be able to recognize faces in order to live in a society where people can actually communicate and cooperate.
Fucking Far Cry Primal over here.
And this is what evolution has made our brains excel at. This ability to build an internal model of the world, to have sort of the world inside your head, to imagine what is happening around you even if you don't see it. This is of critical importance for a true artificial intelligence.
AI, like Google Image Recognition, Alexa, or the autopilot in a self-driving car, all work thanks to neural networks, software which already tries to imitate the way our brain recognizes patterns.
One thing that today's artificial intelligence needs in order to be able to perform whatever task it was designed for is a lot of examples. So in order for Google, for example, to be able to show you pictures of cats whenever you type in cat, it needs to have seen millions of images of cats. That is certainly not how we humans operate and learn. When you show a child, for example, a cat or whatever other new thing, it just needs to see it a couple of times in order to quickly grasp the main features that are specific for that animal and then recognize it whenever it sees another individual of this species.
Duck.
The scientists at Heidelberg University are working on a different part of the Human Brain Project. They're using the brain maps developed by Professor Amunds's team to build computer hardware they hope will help AI learn like our brains do. This new hardware is called neuromorphic, which means formed like neurons, or like the brain.
Oh, shit.
Actually, none of what you see here on the outside is really neuromorphic. You might be tempted to think that this is more or less like the machine that you have at home on or under your desk. This would be true for the outside components, but at the heart of the system, there lies a piece of hardware that is fundamentally, radically different from the chips in your computer, and that is the neuromorphic heart of the system.
The microchips on these wafers look nothing like the entangled web of neurons that we have in our heads. But each component communicates like an individual neuron by sending along...
See, there's the guy. They're putting the guy in the chips. They're going to control. No! No more!
...spikes of electricity to their many partners. This design immensely increases the operating speed. Neuromorphic hardware generates results 10 million times faster than conventional hardware.
We certainly believe that this will become a big thing. We will see many...
Motherfucker, that's going to be the next... That's going to be NVIDIA's 5000. That's what you just showed me. That's going to be... They're going to put it in a square. They're going to put it in a fucking rectangle bracket. And then, boom. It's going to have yourself a NVIDIA 550. Or 5050, what it was called.
Applications of these
50% brain,
for
50% computation.
Tasks. One of them would be face recognition, pattern recognition in general, speech recognition, the ability to read text. The ultimate goal, of course, is to create true artificial intelligence. But it's really hard to say by when we will be able to actually copy the brain in an artificial substrate. What we can certainly do, and what we are doing right now, is understand particular aspects of computation in the brain.
The 4 million artificial neurons packed into this neuromorphic computer are just a tiny fraction of the 86 billion neurons in the human brain. Still, it's a big step forward for the machines. Even though our knowledge of the brain has increased over the last few decades, it's still fragmented. If the Human Brain Project is successful, it could bring this knowledge together and encourage research and collaboration across different scientific fields.
Fuck yeah.
And so this effort could be just the beginning of the journey.
Better understanding the human brain is really one of the challenges of the 21st century. We have an increasing amount of people suffering from neurodegenerative diseases.
Yeah, if you could just remove the anxiety bug, the mental stress bug, the self-conscious bug, OCD bug, the ADHD bug, the ADD bug. Yeah, just like, you know, if you could just you could just swipe all that out when you're building this part. There you go. That'll do just fine.
Suffering from major depression, other psychiatric diseases. We need to have new tools to diagnose and have better therapies for these brain diseases. And since we are living in an aging population, these diseases, of course, play a major role in the future.
AI. AI. Cool. Hey. Y'all, I gotta go boom boom real quick. I'll be right back.
Class dismissed! His name is Professor Voltage. Professor Voltage. Professor